Good morning, ladies and gentlemen. In this video, I'm going to be talking about the solubility rules for ionic compounds. You're going to need to get out your periodic table of elements, so the blue periodic table that we haven't used in ages. And the other thing that you're going to need is your polyatomic ion sheets. And then after a while, you might not need them anymore. You should be following along at the top of page 3 with what I'm talking about today. All right, the first thing I want you guys to do is to number 1 through 6 on the left-hand side of this table. So just write down 1, 2, 3, 4, 5, 6. This number basically is just going to tell us the order of what we should be paying attention to. Alrighty. So, next thing we're going to look at is just our first rule. So it says alkali metals and ammonium salts are always soluble. So if something has an alkali metal or it's an ammonium, then it's always soluble. So let's think about what an alkali metal is again, and here's where the periodic table is going to come in very handy. Your alkali metals are column number 1 on the periodic table. Any of these elements, if they're in the compound, it is always soluble. Okay? No matter what, okay? It trumps the rest of the rules. Nothing else matters. If something has an alkali metal, it is soluble. So indicate yourself on this little cheat sheet here, I guess, or decide where you're going to be putting these notes for your end of the unit test. So I would do it in your packet of fun. But the alkali metals are your group 1 elements. Okay, and that's lithium through francium. All right, now the other part of this says ammonium salt. Okay, ammonium, and if you remember, take a look at that polyatomic ion sheet. Ammonium is NH4 with a +1 charge. Okay, so these are all positive. So if something has a positive alkali metal, or if it has a positive ammonium, then it is always soluble. Okay, so these are the cations of your ionic compound. Next section, we have acetates, nitrates, chlorates, and it says that these are always soluble as well. So we have to remind ourselves, what is an acetate, a nitrate, and a chlorate? Take a look at that polyatomic ion sheet, because all of these things have 8 endings, and if you remember, 8 endings are negative polyatomic ions, and you're going to find their formulas on your polyatomic ion sheet. So as you see acetate, you should be spotting CH3 COO, and this has a -1 charge. Nitrate is NO3 with a -1 charge, and a chlorate is ClO3 with a -1 charge. All of these are anions, and I actually think from here on out, everything is going to be anions. Okay? Now, if these are present, and again, it trumps all the other rules. These don't matter. If these are present, it's always soluble. So these 2 sections, the first 2 sections, are soluble. No matter what else it's bonded to. Okay? And these 2 rows trump all other rules. I'm going to make this a little thicker. Whoa, too thick. Okay. All right, next up, we have halides. Now, halides is another word for halogens. Okay. Halides is another word for halogens, and if you remember on your periodic table, your halogens are group 19 or like 9A, I think, elements. Okay, so these are your halogens. They're the ones with 7 valence electrons. If you have a halogen, and if you guys want, actually, you should write group 7/17, okay, in there. If you have a halogen, they are soluble except SLAM. So on this side of the table, I'd like you guys to write down what SLAM means. And what SLAM is silver, lead, and mercury. Okay, so if something has a silver, a lead, or a mercury, then it is not soluble. If it has a halogen and no silver, lead, or mercury, then it is soluble. So write that down. We have silver, we have lead, and mercury. If it has silver, lead, or mercury, it's insoluble. If it does not have silver, lead, or mercury as its positive cation, then it's soluble if it has a halogen. All right, next up we have sulfates. Here's another 8 ending. It's our polyatomic ion sheet, so you're going to want to look up what a sulfate is. And you should be finding an SO4 with a -2 charge. If you have sulfate as your polyatomic anion, generally they are going to be soluble, and there are a couple exceptions. Okay, here we have Berserker SLAM. So Berserker, we have Ba, Sr, Ca. So we have barium, strontium, and calcium. If you have a sulfate, if you have barium sulfate, it's insoluble. If you have strontium sulfate, insoluble. Calcium sulfate, insoluble. But anything else other than the silver, lead, and mercury, anything else that sulfate is with is going to be soluble. So again, this is the exceptions. If it's with barium, strontium, calcium, silver, lead, or mercury, then that's going to be insoluble. But anything else it's with is going to be soluble. So our little label for this one up top, our first 2 rows were soluble. Our second 2 rows, we're going to write that it's usually soluble. Usually soluble. Next up, we have hydroxides. A hydroxide is an OH polyatomic ion, and it has a -1 charge. So again, this is our anions that we're looking at. Hydroxides, let's see, majority is insoluble. Okay, so this is different than the previous 2, which were usually soluble. So if something has a hydroxide, it's generally going to be insoluble, and our exceptions are the B bases. We're going to find this on our periodic table. Okay, and I'll show you where the B bases are located. So take a look at your periodic table. Our B bases are located, it's all the alkali metals, okay, all the alkali metals, and then next to calcium, it goes, next to potassium, it creates like a little lowercase b. So our B bases are lithium through francium, and then calcium through radium. So calcium, strontium, barium, radium. Those are our B bases. Okay, and I'll draw a little B there. All right, those are the B bases. If something has a B base as the cation, then it is soluble. Okay, the B bases would be soluble. Anything else is insoluble. So if you'd like to write it on your table here, because again, this will be very helpful for your testing quizzes. Your B bases are lithium through francium, and then calcium through radium. Last up, we have phosphate, sulfide, carbonate, oxide. So these are majority of these are polyatomics. The IDE endings are elements and their normal charge. So a phosphate is a PO4 with a 3- charge. Sulfide, because it has that IDE ending, that's a normal element. So this is just a sulfur. And if you take a look at the periodic table, sulfur is right here. Whoa, sorry. I need to get out of this function. Okay. Sulfur is here. And it has, let's see, we have 1, 2, 3, 4, 5, 6 valence electrons. Okay, so sulfur has 6 valence electrons, so it's going to gain 2. So any sulfur, if it's an anion, it has a -2 charge. Carbonate is a polyatomic. It has that 8 ending on there. So we have CO3 with a 2- charge. And then an oxide, since it's IDE, we know it's just a plain old oxygen. Oxygen has 6 valence electrons, just like sulfur, so it forms a -2 charge. Okay. All right, so anytime you have an anion that is a phosphate, a sulfide, a carbonate, or oxide, it's insoluble. And again, I'm going to remind you, the number 1 rule at the top trumps this rule. So if we were to have lithium oxide, it is soluble because lithium is an alkali metal. So make sure that you go in order, check your cations first, and then if your cation does not meet one of the requirements of rule number 1 up here, then you can pay attention to all the anions in rules 2 through 6. Okay, but again, that first chunk is overrides all the rest. Okay, so down here we're just gonna write insol. And then I'm gonna work through a couple with you to help you to think about these things. I would write down at the bottom, and I would maybe put it in a different color so that you remind yourself to look at it. Remind yourself that rule number 1 about the alkali metal and the ammonium salts is like basically the trump rule. So unless you have an alkali metal or ammonium as your cation, you can just skip to the anion. Oops, let's do skip to anion. So unless you have an alkali metal out front, then you're going to be comparing and trying to follow the rules for the anions. Okay, I will do number 1 and number 6 with you. Okay, and then you guys can do the rest. And then this practice down here is just like dissolves like. And then I do have a couple ionics in there that you'll want to follow the solubilities in order to see if they're going to dissolve or not. And for these, you can just put check marks on there. All right, so we'll do the first 2 together, and then you guys can work on that homework. It really doesn't take too long. It shouldn't take you longer than probably 10 minutes to do all of it. So here we have barium hydroxide. All right, barium. We want to check first to see if it's an alkali metal. And actually, I am going to bring back my notes because I do have the periodic table in my notes here. So barium, on the periodic table, it is not an alkali metal. Barium is a B base, but it's not an alkali metal. So it says here that then we want to skip to the anion. So here we have barium hydroxide. So we want to go to our rules for hydroxides. Here are rules for hydroxide. And it says that it's insoluble. So chances are this is going to be insoluble. It says it's insoluble, except B bases. So we want to see if barium is part of the B bases. And if it is, then it's soluble. If it isn't, then it's insoluble. So barium's right here. It is a B base. So this particular compound is soluble. And I need to find my little guy. So we're going to write soluble in there. Okay. Silver chloride. So we want to check and see if silver is an alkali metal. Silver is a transition metal. So we're going to jump to the chloride. If you find chlorine on the periodic table, chlorine is a halogen. So we need to follow our rules for halogens. So that's in row 3. It says halogens are soluble unless it's bonded to silver, lead, and mercury. This chlorine is bonded to silver, therefore it is insoluble. Alrighty, and that's kind of how you go along with these. So your classwork today is to complete these 2 areas and submit them to my WJ. I hope you guys have a good day.